In this video, we are going to discuss some of the multiple choice questions from the chapter Light, which is frequently done wrong by students. The first question is the nature of image formed by a convex mirror when the object distance from the mirror is less than the distance between the pole and the focal length. Now, most of you do it wrong because you consider this, you do not see this, that this is a convex mirror, right? So what we know that irrespective of the where is the object placed, right? In case of a convex mirror, except for the infinity, wherever I place this object, wherever this object is placed in front of the mirror, whether it is twice the focal length, whether it is the closest point to the mirror, or it is equal to that of radius of curvature, or equal to the length which is that is equal to focus, right? So irrespective wherever the object is placed, the image formed is always, it is always formed between F and, right? Between F and P, it is always virtual and always erect. Now, why it is wrong? Because you correlate this answer with that of a concave mirror, like in case of a concave mirror. Let me show you. We have a case where, yeah, this one. So consider this to be a case of a concave mirror where the image formed is virtual and erect. Yeah, this one. So you consider this case, that is the object is placed over here, then it is virtual erect. That is correct, but that is in case of a concave mirror. Over here, our question is a convex mirror, and we should know that in case of a convex mirror, irrespective where is the object placed, the image formed is always virtual, always erect, and always smaller in size. So the correct answer for this should be virtual, erect, and diminished. In the next MCQ, we have two big mirrors, A and B, fitted side by side. A man is standing at such a distance from the wall that he can see the erect image of this face in both the mirrors. So as of now, we can say it can be plane, concave, or convex, because all of them forms an erect image. But then when we read it further, it says that when the man starts walking, right, when the man starts walking towards the mirror, that is right towards the mirrors, that means one by one, he finds that the size of his face in mirror A goes on increasing and that of B is same. So one thing is very clear from here, that the size of the image remains same, has to be a plane mirror. So we have just one case of a condition where the B is a plane mirror. Now, using the elimination method, B is a plane mirror, then there's only one such option where the B is a plane mirror, right? So we can say that it has to be this only. But remember, if there are more options, right? What we can see that in case of a concave mirror, let's say if I take a case of a concave mirror, as you bring the object, right? As you come closer to come closer to this, it's getting dragged. Leave it. As you come closer to the mirror, you will find that the image here, the size of the image also increases, right? Say this is the mirror here. If you come closer, if you bring the object closer to the mirror, you will see that the size of the image also increases, right? The size of the image keeps on increasing, so it can be convex also. So as of now, looking into the using elimination method, we have just one pairing where the B mirror, which has certain here, is a plane mirror. The A can be concave or convex depending upon the question. In the next MCQ, the question says which position of an object will produce a magnified virtual image of a concave mirror whose focal length is 50 centimeter. Now we should see the case of a concave mirror. As you can see, there is the only one case, right? This is the case when the image formed is virtual and erect. That's the only case when the image formed is virtual and erect and it is enlarged, right? This is because we are doing concave mirror. So in case of a concave mirror, it is virtually enlarged when the object is placed between between F and P. Now we know that the focal length here is given as 15 centimeter. So anything which is less than 15 will make the image virtual and erect. So we can see these are more than 15. So the only option is 10 centimeters. So the correct answer is 10. When the object is kept between F and P, the image formed is virtual, erect, and enlarged. In the next MCQ, it says an object is 100 millimeter in front of a concave mirror. Which of the following will produce an upright erect image? Similar to the previous question, and whose radius of it's given that the object is placed in front of in front of a concave mirror at a distance of 100 millimeter, and we have to find the radius of curvature in that case. Now, as you know that the object here is placed at a distance of say 100 mm, we can consider this to be 100 mm, right? So if this is 100, so clearly this will be more than 100, right? So once again, if this is 100, let's say this is 100, this is 100 millimeter, right? Where according to the question, where the object is placed and the image is virtually erect. So if this is 100, so clearly this, that is the focal length, will be more than 100. And if this is more than 100, then what do we know? That this will be more than 200, has to be. If this is, if this is according to question is 100, then clearly this will be more than 100. And we know radius of curvature is twice the focal length. So it will be more than 200. So in that case, we'll say that more than 200, that is option D is the correct answer for this. In the next MCQ, it says a ray from the sun converges at a point 15 centimeter in case of a concave mirror. So what do we know that when sun, which is acting as an object at infinity, and when the object is at infinity, what do we know? That the image is formed at focus. So the image is formed at focus here. So since they are saying that the image is formed at a distance of 15 centimeter, we conclude that here the focal length, that is F, is equal to, so in case of a concave mirror, it's minus 15 centimeter. Ignoring the sign, we can say it's at a distance of 15 centimeter in front of the mirror. Now, the next part, it says where should the object be placed so that the image is equal to the size of the object. So we know that this is equal to the case this when the object is placed at C, the image is formed at C only. So when the object is at C, the image is formed at C and it is equal in size. So if I say that the focal length is 15 centimeter, clearly the radius of curvature, which is this distance, has to be twice of this. That is, if I considering the sign convention, it is minus 30 centimeter, and ignoring the sign, if you talk about just the distance here, it has to be 30 centimeter. One more time, when the sun's ray is converging at a point of 15 centimeter in concave mirror, indicating that the image is formed at focus, and therefore we can say focal length is 15 centimeter. Now we know that the radius of curvature is twice its focal length. Further, we should know that we have to find an image which is equal to the size of object, and that is possible when the object is placed at C, that is, which is twice the focal length and which is equal to 30 centimeters. So this would be the correct answer. In the next MCQ, it says the magnification produced by a rear view mirror fitted in a vehicle. What we know that a rear view mirror is a convex mirror. And in case of a convex mirror, except for the object when it is in infinity, in all other cases, the image formed is always virtual, always erect, and always diminished, right? So we have you can see that the case, this one, is virtual and erect. Irrespective, wherever the object is placed in front of the convex mirror, the image is always virtual, it is always erect, and always diminished. You can see it is diminished indicating that the size of the image is smaller than the object. And we know that in a case where the size of the image is smaller than the size of the object, we get the magnification as less than 1, ignoring the sign, as I said, right? So here the sign is positive, as you know, it's a virtual, so it should be less than 1. That is the correct answer. In case of a convex mirror, we should know that magnification is always less than 1, reason being the image is always diminished.